Hello, hi, I am Ram Mohan. I am working as head of the department for Electronics and Communications Engineering section. Currently, I am placed at Government Polytechnic, Mahbub Nagar. The topic we are looking is the classification of inductors. So, the objectives of this session will be as follows. So, on the completion of this session, one should be in a position to understand the types of inductors, and we'll also discuss about the specifications of inductors in the other half of this discussion. Let us recap what we have learned or discussed so far about the inductors. So we have discussed so far about the mutual inductance and the coefficient of coupling. Now let us come into our topic, that is classification of inductors. Now they are actually classified on different factors, and here one of the factor for the classification is the core material used. So here, on the basis of the material used for core, they are classified as air core inductors and iron core inductors. Then you have ferrite core inductors. So yeah, so there are three types of classification based on the core. Now it is air core inductor. So there is air core means what? So there is simply a coil and there is nothing inside. So there is nothing but air which is inside of this coil. So in this only air is going to act as a core. We'll see that in the next figure. So their inductances are limited to low values. So the value of the air cores will be very less. Like if you want more inductance value, we cannot achieve it by using air core. So this is a simple example where you have a thick coil and there is nothing inside. And you also have another one on the right side. And then let us see some more details of this air core inductor. So if you design this air core coil, so it will be like this, having a length of the winding area, it's a length on which it is wound, and also it have to know the d, the diameter of the inductor on which this has been wound across. Now let us see the symbol of a air core inductor. The symbol is as below. It is simply a coil with two ends. There is nothing within the core, so it is left open. Now let us look into the next one, that is our iron core inductors. So in these, inside the coil of the wire there is a iron core. That means the core for inductance is wound over an iron core, and it may or may not be circular, it can be rectangular, the one which we have seen in our previous discussions. So in these, a coil of wire is wound over an iron core simply. Now they possess comparatively much larger inductance values when compared with that of the air core inductors. So here we see these are iron core inductors. Left one, right side is another model, another size actually, and this is the schematic drawing of the iron core inductors. So there is only one side because it's L, there is iron core. We are not talking of other coil, then it becomes mutual. So this is only simply iron core, where it is represented in the figure at the bottom. Now let us see the symbol of the iron core. Yeah, here you can see. So thus in the symbol we can see that next to the coil we are drawing two parallel lines, that is actually indicating the iron core. Now let us see our next type, that is ferrite core inductors. In this type of ferrite core inductors, a coil of wire is wound over a ferrite core. So here the material used is ferrite solid rod or piece, whichever shape you want. And here these coils have very high inductance values. So for very small value we use air core, for relatively larger values we can use iron core, and still higher values we will be using ferrite cores. And here you have the figure for the ferrite cores inductors. Yes, here you can see there is ferrite core inside that black one, cylindrical. Well, and you have another one on the right side. So there is a plastic bobbin, or the bobbin itself will be of ferrite core, and there is one more model at the bottom with a screw. That means you can vary sometimes the linkages that is making with the coil. Yeah. Now the symbol of the ferrite core inductor. So in the symbol you can see the coil with two ends, and there are two parallel lines, but they are dotted lines. So this is actually indicating the ferrite core that is used for the notation of the ferrite core, symbolic representation of the ferrite core. Let us see the next one. On the basis of the frequencies used, once again these inductors are divided or classified into two types. They are audio frequency coils and radio frequency coils. So let us look at these audio frequency coils. Audio frequency coils will have several hundreds of turns on the iron core to give high inductance value at their frequency range up to 20 kilohertz. What is the AF range? It is 20 hertz to 20 kilohertz. So in this type we will be using so many turns, hundreds of turns on a iron core. Now let us see the RF coils. So these coils have smaller inductance than AF coils. on the smaller inductance than AF coils. And again, on the basis of the winding, you have two more classifications, that is single layer coils and then multi-layer coils. Now let us see the single layer coils. So this is the coil in which single wire is wound over a core. That means one winding is wounded on the core. Simply only one after the other coil winding, and it is not on the overlapped rather. Then multi-layer coils. So this is in which two or more wires are wound over a core. That is a multi-layer core. Then on the basis of the operation, these inductance coils are once again classified into two types. One is fixed coil and the other one is a variable coil. That means in the fixed coils, the value of the inductance will be fixed, and in the variable coils, you can vary the inductance to best suit your requirement into the circuit. That means they are variable by some means. Let us see how they will be implemented. There can be a screw of a right core that is linking it, or there can be movable ferrite core within the coil. So like that. Fixed coils. So these offer a fixed inductance. So the value of the inductor that will be used here will be having a fixed value. You cannot change it. And these will have no provision to alter its inductance. And so only we are calling them as the fixed coils. And let us see the symbol for the fixed inductor. Here it is. It is a simple one coil with two ends. Now that is variable coils. Here these are the inductance or the coils whose inductance can be changed over a specified range when required. And the symbol is as below. Here itself we are showing it. So you have two ends for the coil and there is an arrow across the coil, so which indicates that the coil inductance is variable. Now let us summarize the things we have discussed so far. The inductors can be classified based on the core material used, the frequency of operation, the type of the winding and their operation, means their value if it is fixed also. So based on the first one, that is the core material used, we have air core, ferrite core and iron core. Then based on the frequency, they are divided into audio frequency coils and radio frequency coils. Then based on the type of winding, how many are there? Once again they are again two. One is single layer winding and then multi-layer winding. Based on their operation, that is about we are talking about the value I like. So they are divided into fixed value inductance and a variable inductance. Now let us have a small quiz to recall our memory, to check our memory here. The ferromagnetic materials have higher value of relative dash. Choice A is permeability, B is permittivity, third choice is both, and the fourth choice is none of the above. Here, what is the right answer? It is permeability. Now let us see the next one. Dash coils have smaller inductance than AF coils. What is the right answer here? Now, before that, let us actually get into let us see the choices of that one. First is IF coils, second is RF coils, C choice is both, D choice is none of the above. So we are comparing them. So we are trying to see which coils will have smaller inductance than that of AF coils. So the right answer is RF coils. So here you can see the coil, RF coils. B choice is the right answer with blue color there. So now let us see some frequently asked questions in this topic. Yes, it is this. Give the various classifications of inductors. So based on different factors, you have different classifications and different names for that. So with this, let us pause for the next session for a while.